Hello, should be live now. Let me put this guy here and start casting. Cool. How you guys doing this morning? If somebody wants to let me know in chat whether the audio is good. Why is this flickering? Why does this flicker sometimes? There we go. Hey, Hyperbanner. Thank you. Good day to you too. Don't have audio right now? No worries. And hello, I don't know how to say your name. Euro Pi open close squirrely. Let me go ping the Discord real quick, and then we'll give people just a minute to get on. That should do the trick. Hey, Jappy. What is this? Lovely. Okay. Let's give 1 minute more, and then we'll start. You guys might have noticed I've been doing, hey God tier Slayer. I've been doing pretty much, well, the last, well, I can find out how many. Where is this? Content live. Yeah, this is the 4th stream in a row that's been programming, like, lovely related, as opposed to the OS. Just because, not because I've given up on the OS at all. It's just that I really want to get, I kind of made a decision not to go super far with the operating system before I have Lovely ready, so I don't have to do a huge rewrite. So just definitely focusing on Lovely right now. It's kind of cold in here. I'm gonna grab a sweater. Okay. Should be able to start now. Cool, we got some like Chinese text or something in the chat that I can't read, but hopefully it's something friendly. All right, so where were we? Last time we pretty much spent the whole time, we literally spent the whole time talking about syntax, right? So we made all this new syntax. I just wanted to, this time, I'm hoping to just be coding pretty much the whole time. I just wanted to address a few things that Jappy actually pointed out in Discord. Just like small revisions to the stuff we decided on yesterday. So let me pull up his message Just saw your channel a few days. Do you have any prior knowledge about this, or you just learn the way you go through? I'm just learning as I go. Yeah. You mean about compiler dev in particular? I've never made a compiler. I've done a little bit of like, well, I've done some lexing and parsing before, but I've never done actually like a real compiler. So your suggestions: 1, separators for attributes and variants. I thought that was a good idea. So we took out semicolons, right, which makes everything look a little cleaner, I think. But then Jappy suggested, why not just take out commas in these things too, which I think also kind of makes sense. It makes it look even cleaner. So yeah, I'm up for that. I think that looks nice, doesn't it? With no commas separating them. Because you don't really need commas. It's pretty easy to parse. So this doesn't need a comma, this doesn't need a comma, this doesn't need a comma, this doesn't need a comma. This doesn't need a comma. Oh wait, these do need commas. Oh wait, okay, so question. Like constructing values still do need commas, right? It's just the definitions, right? Okay, so this does need commas. I think. Right? I mean, would it make sense for this not to have a comma? I don't think so. Like, what about this case? You kind of need a comma here. Otherwise, that'd be really weird. Yeah, so we'll keep commas there. Also use of dot. Oh yeah, good point. This should be an at. Good point. Have we done that anywhere else? No, okay. So that should be at dog. This should be at cat. What's the purpose of your OS? The purpose is just to learn. Oh, hi, ICXD. Just to learn. We'll do that. And then here we'll do that. Here we'll do that. Somehow this one never got past the semicolons. Does that look good otherwise? Yeah, okay. And then that looks good. Although this should have to have that now, doesn't it? This is just kind of, this isn't accurate anymore. One free variant called default, right? And this, when using the default, you have to use this $sign. So we'll do that. And that gets kind of explained later. The access methods like that. Cool. This still makes sense. Oops. That's good. These still need commas. This needs commas. This. There we go. And then okay, I feel like we already talked. Okay, for some reason I redefined all this stuff down here and I forgot to remove it from above. So I think I can get rid of all user defined types from up above, right? Because I just reintroduced it down here. Okay, so all this stuff up here, that's why this stuff was out of date. That makes sense. Yeah, we don't need that. Okay. So user defined types are now introduced down here. These still need commas. This one doesn't have commas. These ones do have commas. You can nest these things. Perfect. That also makes this look better because originally these had commas, this ones didn't, but now neither of them have commas, so it's good. You can nest types. Hey, bacon. Hey, crazy nunchucks. If you could maybe keep chats a little bit more on topic, that'd be great. You're working on a physics framework for fluid sim that remains efficient over network sync. That sounds really interesting. This guy doesn't have these. This guy wouldn't have that, right? And then you don't have that. Oh yeah, and also in matches too, right? Was the other place where you're gonna do that. We'll still use them in here because this is like a list. Anywhere down here I'm using them where I don't need them. Okay. So that was the first comment. Separators and type definitions and separators and match. Did I have any other matches I need to deal with? That's the only match I have. Okay. So we just don't need a comma here anymore. Which I thought, oops, I thought was a good idea. So, oh yeah, and then are we no longer learning ASM and OS Dev and instead working fully on Lovely now? I kind of just explained that a little bit. I think right before you got on. This is like the 4th stream in a row that's been Lovely, right? It's more that I don't really have time to do 2 streams. Well, I kind of changed from doing 2 streams in a day to doing one slightly longer stream a day, so it's not quite as much time for me, and it's kind of all condensed into one part of the day. And because of that, not that that'll always be true, but generally speaking, because of that, I kind of can only focus on one thing, and I also decided that I would really like Lovely to be ready like a little sooner than it would be otherwise, right? So that I can start using it for Humble, but Humble is totally still the end goal. It's just I decided to, I don't want to go super far with Humble in like Rust or something and then have to rewrite it, a huge thing in Lovely. I'd rather do as much Lovely from the beginning as I can, if that makes sense. So because of that, I've been focusing more on Lovely, but anything else in here? Oh, I don't need that comma. What made you start streaming your journey? Well, I was doing videos. Oh, wait, I don't need this either. I was doing videos from the very beginning. I think I only did like 9 of those or something. So just every morning when I would do this, I just videoed it and like uploaded it. Just mostly just to keep me motivated, but then people started kind of finding them, so that's kind of interesting. And then people started, giving me feedback and stuff in the Discord and in the YouTube comments, and I was like, why don't you just give me this feedback live? And that'd be fantastic. And so then started streaming it. But yeah, I was videoing from the beginning. All right, any other comments to take out? Okay, so then it was the whole self and methods for protocol. So like, where do I have a protocol? This was definitely a good one. It's like, this is bad because this is not a function definition. This is just a function type. So you don't say self here. You'd say mut a, right? Or is that what you? Yeah. So this would be the type. Any other protocols? That was the only protocol, right? Okay. And then compiler warning for if, some, else, none. Yeah. So if expressions return if expressions already, so you said that this should be a compiler warning, which I think is a good idea. Our compiler doesn't do warnings yet, but in theory, this entire thing could be replaced with that could be replaced with if x is greater than 8x times x. because these already return optionals if there's no else branch. And so I basically at that point would need to figure out another example because I'm trying to demonstrate optionals here. So I guess this wasn't the best example. How could I do this? What's an example that demonstrates? Maybe I'll just leave this and have a comment here. How if expressions work, the above line is equivalent to this. All right, I'll just leave that as a comment because this is just to demonstrate that. Okay. Cool, that was it, right? And then you didn't like the $sign syntax. I think I'm gonna keep that for now. I kind of like that, having default variance as just $. I think it's fine. Because if you do more than another character, like that or something, like you're suggesting, then it doesn't line up anymore. Like I like how these are aligned. Would this also work for functions where not all branches return a value? That's interesting. The whole optional thing. I didn't think about that. I don't think so. Because you'd have to annotate function return types. Hats off to you for building a language from scratch as a side project at 7 a.m. Thanks. What's the $sign doing? $sign. Sorry, that one's, I'm not using it. Yeah, $sign is a default enum variant. So if I was constructing a list, right, then I would have to say, you know, but I'd say my list, Micaiah is a morning person. Yeah, I don't think I'm naturally a morning person. Like if I let myself, I'd sleep in sort of late, but I kind of make myself be a morning person. My list, if I want to construct a list and you have to say list and you pick a variant, like I could say empty, right? Empty, I don't have to construct because it doesn't take anything, but if I did cons, then I'd have to, you know, fill in these values, whatever. Or not like that, it'd be like this. So then if I want to make like empty be the default so I don't have to spell that out every time, I switch this to a $sign, and then this can just become that. And then it just chooses the default one. And this becomes particularly handy when you have things, when you want something that's like a struct in another language. So if you have like type foo, and say its variance, say it doesn't have any, or you don't specify any variance, right? So you just have like bar is a string, and lorem is an int. Hey, Kakashka. Or I still don't really remember how to say your name, but something like that. If you have something that doesn't have any variance, it just has fields like this, then it's as if you had done this and specified one default one that's called default, right? Because when you do this, you get to do this, right? And then specify these. Like that. So does that kind of make sense? You get one for free, one free variant if you don't specify any, because you need to have one variant or you have another type. So that's that. Do you usually prefer waking up early to do side projects over staying late at night to do them? I can't stay up late at night and wake up early, or I just am really tired. So I chose the morning over the evening. I don't know why. I feel like the morning's nicer. Could you just use a dollar in pattern matching to match the default variant? Ooh, that's interesting. Like if empty here was the default one, could I just do this? Is what you're saying? Is that what you're asking? I don't know. Does that seem like a feature you'd want? That seems maybe cool. Yeah, sure, let's allow that. I mean, we're at the point where we're not implementing anything, so we'll say it's fine. How do you declare the extension of the source code file as LV? What do you mean? How do you declare the extension of the source code? Just when you make a file, you just call it syntax.lv? Wait, what do you mean? How do you declare the extension of the source code file as .lv? That's just purely convention. Because like you could write Rust in a any txt file if you want, and Cargo would be maybe not happy with you, but that's just because Cargo uses a convention, right? It can be whatever. It doesn't really matter what. File extensions are just for you and package managers and stuff. So like that you chose morning, lol, otherwise I wouldn't be able to watch. Okay, yeah. All right, so that should be all the things. So now let's go try to implement all this stuff. So we've gotten fairly far implementing a bunch of other stuff. I'm not going to implement all this at once. I'm going to implement. I'm going to finish implementing the stuff that we started implementing, right? Adjusting for the new syntax, and then yeah, this is going to be interesting. Okay, got it. I thought file extensions mattered. I thought you had to specify elsewhere that your lovely file was .lv. Do you think one day you're going to create a logo for lovely? Yeah, I mean, it'll eventually need a logo, I guess. Yeah. I thought about doing like some sort of like competition in the Discord. Not like a competition, but like everybody submit your logo idea for lovely or for humble, and like then having people vote on the best one or something. I thought that might be fun. Otherwise, I'll just give it a shot, but I'd probably enter if I did do that. Oops. This was just an example. Okay. All right, so as far as syntax go, I kind of want to be testing this as we go, so maybe we'll start with fixing some of these. Oops, not those. Well, actually, you know what? Variable decals and operators. These are all working, right? Yeah. Okay, wasn't there something broken in the checker? I think I'd commented out a bunch of stuff. Yeah. Oh, because I started making function types. That's how this whole entire syntax discussion started, is because I was just making function types. All right, this is going to be a little bit annoying. All right, so comment that back out. And then I'm just going to go into my test thing here. I'm not going to test the checker for now. Right, so then I should be able to coding today? Oh yeah, pretty much every day. Okay, so if I cargo test, We get those, okay. These should all be good. Just make sure they're not errors. Okay, so that should have given me what? 8 tests? 1, 2, 3, 4, 5, 6, 7, 8, yeah. Ooh, Insta. Oh yeah, we got Insta. Alright, because the checker's totally broken, so we're just not going to test this for now. But just get the Lexer and the Parser back working because I changed the syntax a little bit. So what I'm going to do is I'm going to go into these tests and update them to the new syntax. So, which should break everything. For instance, in this one, there's now no semicolons. That should be the only change. Alright, this one, there's no semicolons. Everything else should be the same. Yep. This one also should be the same without semicolons. This one, yeah, okay, so pretty much all these are kind of the same because we were only doing trivial tests, right? Although this one was kind of advanced, right? I mean, not very advanced, but inferring the type of C was pretty cool. So try to see if we can get it back to that point. If there's no semicolons, what's your language's way of discarding a value? Well, I kind of realized the whole discarding a value thing, we weren't really using that, were we? So I don't know if I really need that whole concept. Like, where would I have used that concept? To return unit from a function is kind of the only place I can think of. Otherwise, what? Okay. So we changed those. It should now, if the last line is a function call and you don't want to return the result of the function call, the final expression of a block, but I guess you could just return unit afterwards. Yeah, you can always just put unit afterwards if you really don't want the, like, there's not really a reason you would be using a block. Often writing the compiler in its own language is one of the best parts of the language. Best test of the language. Thoughts on self-hosting the compiler eventually? I'd love to eventually, yeah, totally. I think that'd be awesome. Did you fix the parenthesized expression ambiguity with function call problems? I don't know if I did. What I was thinking, yeah, I'm not really sure what to do about that. Like if I have foo here, 2 plus 2, like how do I know this is foo 2 plus 2 versus foo and then 2 plus 2 as a line down here? Is that what you're kind of asking? The only kind of obvious way I can think of is if you have some like concept of white space, right? Like if there's white space here, then this is 2 expressions. If there's no white space here, then this becomes foo and then a call, right? Any thoughts on that? I'd say don't use parentheses for expressions and use blocks to wrap expressions. Oh, that's a good point. Because blocks work exactly the same, don't they? Because I could do 2 plus 2 minus or times 3 minus 2. What would a single identifier in one line even mean? Well, nothing. Like, you'd never use that, but there's nothing preventing you from doing that, right? Because the same reason you can just do this. Like, you could just put any expression on a line, right? So there's just no reason to prevent that. But I just realized you're totally right about it. These work exactly the same as parentheses. So how about we just reserve parentheses for function calls? And then if you want to do like this kind of thing, then just use squirrelies. That works perfectly. I think that's a good solution. So if I now cargo test, I should get like issues. Okay, the syntax error. Invalid operator. Left paren. Yeah, we got all sorts of problems now, but it's all right. You just borrowed the idea from Gleam. It also doesn't have parenthesized expressions. Oh, cool. What do I like working with on web front end? Like to build a web app or a static site? That'd be two different things depending on whether it's a web app or a static site. Lately, I've been really, well, not necessarily two different things actually. My recent stack for web stuff has been Astro, and then when I need client interactivity, then I use Solid.js. I used to be a React fanboy, and now I'm a Solid guy. So Astro plus Solid has been my stack recently. Okay, so all right, so I guess we just need to go into our Lexer. Are there any new tokens? They probably are. Okay, so we'll go to Lexer tokens. So we still have fun, we still have unit, we still have true, we still have false. So these are keywords. Let's add some new keywords because we also have some new keywords, right? We have owned, right? We have, oh no, it's not, we named it. It's take, right? Which is take. We have mutt, which is mutt. We have read, which is read. And then we have give, which is give. We also support break statements. Break is a thing. So those are all new keywords, right? Oh yeah, proto, impl, and type. Good point. Proto, impl, type. What about continue statements? We probably will want those, but for now we don't really support them. When you use Astro to use React to build components, apologize for the option. No worries. If it's dev related, it's fine. Do you use React? No, I use Solid. Solid, if you're not familiar with it, is like React, but better. Obviously that's a really, probably not a good take, but that's my take. Solid.js, this is what I use with Astro. Also, have you already considered adding go-tos to the language, you're biased. Are you biased in favor or against go-tos? Pass for continue. Pass is pretty nice. Pass. All right, we'll go ahead and add continue while we're in here. Should we do pass or continue? You're very in favor of them, but then you need like a label system. Aren't they kind of clunky? A lot of people do think they're really bad, and then there's people that think they're fine. I feel like I'll leave them out at least until I feel a need for them. What do you guys think? Pass or continue? Pass is shorter. Pass is good. Which one? Pass, continue. Let's see what you guys think real quick. I think pass is pretty good. Pass. 50-50. Pass. I feel like pass kind of makes sense semantically, doesn't it? Let's do that. Pass. All right, we got pass. Pass. Well, everything's an expression, so it's like an expression that returns unit, I guess. Go-to probably doesn't fit my language's design philosophy, but I could be convinced otherwise. All right, any other tokens? So we don't actually have semicolons anymore, which is interesting. We could use them for something else now, but they're not line terminators at least. We still have all of these, right? At some point, yep. Still have all of these. We have identifiers and then literals and then files. Okay. That should be good. It should return a never type. Oh yeah, because it diverges. Good point. That's interesting. Okay. So there's our tokens. Except we need to add semicolon is no longer a thing, and then we have to add these guys. Take becomes take. This becomes mut. This becomes read. This becomes give. This becomes break. This becomes pass. This becomes proto. And this becomes impl. And this becomes type. Those are keywords. I don't think keywords go here. Keywords go right here. Lovely. Also, do we have an early return keyword? Ooh, we probably do want an early return. Is there a way we could get away without an early return keyword? We probably need an early return. Yeah, we probably need an early return. Okay, so let's, I guess, add one. Gleam doesn't have one. What does Gleam do without one? Because I'm curious about that. Is there a way to get away without one? I think I'd use ret because it's short. It just returns the last expression. So there's times when you really do want to use an early return. That's interesting. The only alternative I can think of is just a branch break out of a loop via if break to end the function. No early return. Yeah, I feel like early return is good. But I'd be curious to hear more about what Gleam does. So we'll add, if it's return, that formatted as ret. You guys find cool with ret for return? So it'd be like ret 8 instead of return 8. It's just a little shorter. And looks more like assembly. I'm kind of into the whole short keywords. None of these are very long, which is nice. All right, so there's tokens. What do we need to do in here? There's no more semicolon. So as far as what I just added, there's just a few more keywords, right? I didn't add anything else besides keywords. So we'll add it's literally all of these, right? It's a lot of keywords we just added. And then I guess I'll use a macro. Okay. Oh dear, this is gonna be a tough macro. Okay, I'll just hard code this in for now. What do you think are the chances I got that right? Shoink? Oh yeah. Subscribed and hi, thank you so much. That was a fun macro. Okay, I just gotta change these numbers. So this one's 4. This one's 3. This one's 4. It's 4. This one's 5. This one's 4. This one's sorry. It's not return. This one's 3, right? This one's 5. This one's 4. This one's 4. This one's 4. 4 and 5. Cool. That should be good. So satisfying when you hit a good macro like that. Yeah, I know, right? All right, see you, Jappy. Thanks for signing on for a little bit. Okay, so this. Some lovely this morning indeed, Empathy Monster. That should, in theory, make our Lexer work. Well, except for there's errors kicking around somewhere. Oh, our tests. I forgot we had tests in here. We pretty much just have this one for all syntax, right? So we'll just do something like that, something like that. I wonder if we should just get rid of this because we're testing everything. Yeah, I think I'm gonna get rid of this test because I don't want to have to maintain this, and we already have snapshot tests. So there's that. Now we're just going whole hog snapshotting. Okay, so in theory, I should be able to go to my test, get rid of all that. Go to this guy, and then just test the Lexer. Should do the trick. Now if I cargo test, couldn't compile. Oh, the parser's broken. The parser's broken. Because we're doing all these semicolon checks. All right. So the parser needs to be reworked maybe before we can. I'm pretty confident that the tokenizer is working, or the Lexer. All right. So how to do this? It should pretty much be the same. Oh, the video's frozen? You're kidding. Why does this happen? No. It's not just you. Okay, 1 second, guys. I'll fix it. This has been happening like every stream now recently. I really need to figure it out. 1 second. You can hear me though, right? Yep, okay. All right, 1 second. There's that. And then there's that, and then drag that down, drag chat above, and then switch to this. All right, there you go. Should be working now. Sorry about that. I should really look into that. All right, so I figured I'll just kind of walk through this parser, kind of like descend into it the same way it would descend into something, and just kind of fix everything as we go. It shouldn't be too bad, I'm not thinking, but you never know. Did we get something working? We got the stream working. That's the only thing, pretty much. Otherwise, we broke a bunch of stuff. All right, so where does this parser start? It starts with this parse thing, which tries to make a bunch of statements. You like the bigger picture size? Looks good. What's the bigger picture size? This guy down here? I feel like this is the same size it's always been, hasn't it? Okay, so we parse expression statements. Okay, so that's the next thing we jump in. Parse expression statement. So this whole semicolon business is like so last week, right? So we're gonna get rid of all of this. Oh, before I switched it? You mean like the big square down here? But then it covers up a bunch of the thing, doesn't it? Do you guys like the bubble? Here, I'll show you the alternative. The alternative is something like this, with me down here, or me wherever. Oops, not that. I go down here. I could go up here. I could go down here. What do you guys like, the big thing or the bubble? I feel like the bubble's a little better, right? Because I'm kind of blocking a lot. Yeah, I'm using OBS. I'm not very good at it, in case you can't tell. I feel like the bubble's better, don't you guys? Okay, who likes the bubble? Do you guys like to see me in a bubble or in my natural habitat? Yeah, maybe it doesn't cover much. I don't know. Which bubble or natural habitat? Please pull habitat. There we go. Wait, this is confusing. What does this even face? Oh yeah. Tied 50-50. Bubble. Bubble's winning. Yeah, I feel like the bubble's a little bit better. Oh hey, you got your face cam the same as the one in your first videos. I always do polls. Thanks. I like the polls. That's how I know what you guys think. Alright, but bubble's winning. We're gonna do the bubble. I agree, the bubble's better. Then I don't have to worry about cleaning my room, because you can see like my yoga ball and my music stand and my bass and everything. It's embarrassing. We're gonna go back to the bubble. So you go over here and then you hide back behind there, and then we do there we go. Back in the bubble. All right, so parse expression statement. Anyway, we were talking about how this check semicolon thing is no more. So no more checking semicolons. Let's go back to parse expression statement. This guy. Okay. So we no longer consume a semicolon. We just parse an expression, basically. So at this point, there's not even any point in having such a thing as an expression statement. Correct? Everything's just a list of expressions. No? Because we removed the concept of a semicolon. Because if you look in the AST, an expression statement is just an expression statement, and whether or not it was discarded, which is just whether or not it had a semicolon. But now that there's no semicolon, that doesn't exist, and so it's really just a wraparound expression, so we can just get rid of expression statement and use expression. So I think I'll do that. Seems good to me. A program is now just a vec of expressions. Any problem with that? What's the matter here? Expression statement. Bodies just become ooh, bodies aren't a thing anymore. Body just becomes an expression, which needs to be boxed. There we go. Okay, so there's that. Arguably, a program is just a single expression. You put all expressions in a tuple. In a tuple? More, I think of it more as a block expression, right, than a tuple. But yes, I see what you're saying. Coolio, this is nice. So now everything's totally broken. Go over here. Parse expression statement is no longer a thing. We don't need that. See, I knew this would make things simpler. So statements just becomes expers. So eventually this whole function here can probably just be generalized into like parse expression list, right? And then you can use it for function bodies, you can use it for block expressions, you can use it for everything, right? So we'll do like expers dot push parse expression, which program takes precedence. Precedence lowest, right? Start with lowest precedence. All right, and then we do this expers. All right, then parse expression is going to be largely the same. We kind of poke around in here, get a prefix parse function, yada yada. All this should be pretty much the same. Dap doo da dap da doo. Yeah, it's all kind of working. What are the errors we have at this point? Parse expression statement. That's not good. What is this inside of? Parse function expression. All right, so parse function expression needs to change a little bit, right? Because we have, we have fun, and then we have left parens, and then we have all the parameters, and we have a right parentheses. Ooh. Here we go. Okay, so we need a because now we have a right arrow, right? Because now we have something that looks like fun, oops, params, and then we have optionally, if there's a return type, there's an arrow, and then type, and then colon, and then body. Correct? I don't understand how you're basically able to keep all this in your head. I lose track at about 200 lines of code. It's not so much that I have the whole thing in my head as much as it is that I'm fairly familiar with each little part of it. And I basically just jump around and follow errors and diagnostics to move around. So, and I just search a lot. I'm always searching. I have no idea where anything is. I couldn't tell you what line of code, you know, parse function parameter would be on, but I just search it. So, and you can obviously do that really fast with, you know, NeoVim. So, all right, parse expression statement. So it's no longer that. We need to do something different here. So first for the return type, oh, we need a right arrow token. We need a new token. Do we have any arrows? Any arrows? No, we don't have any arrows. Okay, we're gonna add a new token called a right arrow. What's a good place for it? Bit XOR. Where's my tilde? Oh, there it is. Syntax. Syntax operators. Okay, this is an operator. This goes here. This is gonna be right, or I guess right arrow. Looks like this. So we need to, oops, shoink, add our match arm here. Right arrow will go right here. And what do right arrows look like? They look like this. Shoink. Okay, very nice. So then there's tokens, and then we need to lex this thing. Here we go. This guy needs to become one of these special these are complicated. It's kind of gonna become one of these, right? So minus becomes this. If we have a minus, then if the next one is one of these, then it's gonna become a right arrow. Otherwise, it's gonna become a minus. Does that look right to you guys? Cool. Lost in the Rust sauce. I am lost in the Rust sauce. Okay, so then for my next trick, over here, we need to like optionally expect this kind of thing, right? If we have an arrow, there's always gonna be a type after the arrow. And then there's always gonna be a colon though, regardless. So how to do this? Right now we're, so we have this peak kind thing. Okay, I'm gonna say if let right arrow equals self dot peak kind, right? We're gonna do that in here. Then we're going to self dot expect token right arrow. Right, we expect that thing, and then this is true. Once I tapped in Rust, I can't get back to any other programming language. Yeah, I love C, but I'm so tired of the UB and edge cases. What's the UB? I'm not a C guy. All right, so if we see right arrow, then we'll expect this. That consumes it, I think, right? This better consume it. Yeah, it takes the mutts off, so it consumes it. And then we need to okay, so then we'll do return type equals some self dot parse type. Ta-da! And now I don't need that. Okay, and then left brace isn't next, but we actually first do self dot expect token expect token. What do we expect? Colon. Oh, I forgot that this can be a question mark. And this can also be a question mark. Oh, that's what the problem is. Okay. So then left brace is a thing of the past. Now it's just any expression. So this whole body jam is just a bunch of baloney. We can now self.pcan left brace. This is no longer correct. This is no longer correct. So we have a colon, and then we just have an expression, right? So we just need, the body is now just an expert. We can just anything not defined by the standard that a compiler can implement any way they want. Undefined behavior. Gotcha. That's interesting. So then we'll just say let body equal self dot parse expression. Precedence lowest. And then you get body. This needs to be this. Shoink. What is body? It's an expression. What's the matter? Oh. How's that? I don't know what this end span is. End span. Yeah, okay, so we need to get the... There we go. That's cool. That's no longer a thing. Hey, it's compiling. Now, this guy is not compiling. Probably because this is not a thing. Well, if it's compiling, it's good enough to test. So, wow, that was like actually a good quote. If it's compiling, it's good enough to test. Let's test it. All right, so we'll just check these. So cargo insta test review. Test these. Are these the tokens we want? What is coming from? This is idents, right? Okay, so idents. Here we go. We have identifier colon equals int literal. That's a right. Identifier colon equals int literal. Identifier colon single equal int literal. That's correct. Identifier colon single equal identifier plus identifier. That's C equals A plus B. Yeah. And then we have an identifier. So that's perfect. That's good. Shoink. And then what's this one? All right. Actually, I kind of know the Lexer works. So I'm just going to accept these ones. Oh, I'm only testing the whoops. All right. We need to go in here and test the parser. Test the parser. Shrink. Let's try that again. It failed. What did it fail with? Syntax error, invalid operator, left parentheses. Where do I even have? Snapshot testing is not something I never considered for my own laying dev. Looks so good. It is so good. I did this like a week and a half ago or something. Yeah, you should try it. Somebody on stream said, hey, you should use this, because I was literally handwriting these massive tests. And then this is just like deleted so many lines of code. All right, so we got issues. And the issues are something I can maybe resolve, but I just realized that the issues are somewhat tied to the fact that I don't actually want to use these anymore. I want to use these. So I might as well fix this while I'm at it, don't you think? Do this. Any other parentheses I'm using anywhere? No. Okay, so that's all that. So then we should get a different error, I think. No prefix parse function for left brace. Perfect. Why are you saying no, Ivy? All right, this is great. This is great. Fantastic. So just going to the parser now. Mod, AST mod, AST mod, AST mod, AST mod. So we have a parse grouped. Grouped expressions aren't really a concept anymore. Okay, so we actually need to go on the AST first. Oops. Expression. We have units, booliterals, inliterals, identifiers, prefix, infix, variable decals, functions, function calls. We need one more called a grouped, not a block expression, right? Block. That is a vec of expression. And we don't have to box that because vec is already heap allocated, correct? That's basically what we do down here. But, no, it's not. Okay, block is a vec of expression. Yeah, that makes sense. That makes sense to me. So we have a block. We need to parse block expressions, which sounds pretty trivial, I think. Test, checker. Where does this go? In here. Shoink. Okay, so grouped expressions are no longer a thing, so get rid of that. And then group. Shoink. Now we don't have that anymore. We will have a prefix parse function. Wait, where did I do that actually? Here. Get that back. Okay. Because I want something simpler. If I have a similar, not simpler. If I have a left brace, then I will parse block expression, which obviously doesn't exist. And here was my parse grouped expression. It'll honestly be kind of like that. What it'll be more like, though, we should get this, right? Hi. And this test error now. Correct. Not implemented. Hi. Okay, perfect. So we have this. Hi. Stay hydrated, kids. Hi. Okay, so basically it's gonna look like a lot like our top level parse thing, right? It's literally gonna be like this, which makes me wonder, man, that's all right. Okay, so I'll take this. Little duplication never hurt anybody. This. All right, what is this called? Block. Pop that in there. So we don't know what expers. What do you do here? All right, this is a little bit different, but the concept is the same, right? So we're gonna return an expression. What's this new thing? Kind block. Um, what do you mean you expect it to? There we go. Okay. Peak is some, yeah, so this is no good. First thing we want to do is we want to say let foo equals self.expect token left brace. Right? This should give us, yeah, a span. Right, okay, this should be this. This should be, you know, like start span. Start span, okay. And then self.lexer.peak. Wait, what is self dot? Let's do this. Okay, so peak self dot peak kind isn't isn't a right brace. I'm gonna get a new expression. And then once it is, then we're gonna say let end span equals self dot expect token right brace. And then what? We got to make a new span here, right? So how do we make a span? From range, start would be start span dot start, and end would be end span dot end. How about that? That pretty much should work, I'm thinking. So now what sort of error do we get here? Oh, no error. Okay, so now we want to stop it. I rejected them. Whoops. That's not what I wanted to do. All right, so let's check these against our source files. So one is this. This is we're looking at what is this from? idents. What made you learn NeoVim? Is that much faster compared to if you know your VS Code shortcuts? By the way, what's your font? The font is one I just got last week. ICXD recommended it, or had it at least, and I thought it was cool. It's called Maple Mono. Is that what it was? Maple. Yeah, Maple Mono. And what made me learn NeoVim? It just was really attracted to me. I was in VS Code. I used Vim motions in VS Code, but this is still faster. Like literally just the app is faster. Like VS Code is obviously Electron and slow and stuff, but also there's just more things, like deep Vim truths. Hey there, pixel checksum. All right, so what do we have here? We have an expression, right? We have an array or vector expressions. The first one is a variable declaration. We're naming a, and we're binding it to an expression that's an int literal 12, and it's mutable, which is perfect. That's exactly what that is. Then we have another expression. Oh, this is just working. Check it out. See, who needs semicolons? All right, we have another expression, which is a variable declaration. It's binding b to an int literal 9, and it's mutable. Perfect. Then we have an expression, another expression, where it's a variable declaration. We're making a variable called c. We're binding it to an infix expression. It's perfect. Which to the left is an identifier called a, and the right is an identifier called b. That's perfect. And then we have another expression at the very end, which is just an identifier c. That looks perfect. Joink. All right, what's this one? This one is lengthy is what it is. Good grief. Operators. Oh, it's because I have this nested thing. which is not good. Let me just make this a little smaller just for the sake of testing. What is this one? Okay, this is the one. All right, here, we'll try to read through this. I'm pretty sure it'll work, right? So we have a list of expressions. The first expression. Oh no, this is not working. Oh, didn't we decide that we were gonna get rid of negative prefix, right? And just have like a dot neg thing to solve this problem. Cause see how this is parsing this as an infix? Where the right is 9 and the left is true and the operator is minus. This is no good. It's parsing this as not true minus 9. Which makes sense. Okay, so we need to, which is why you have tests. We need to, neovim looks so mint. What do we want here? Hey, Andre Montero, in response to your question about neovim being faster and stuff, I'd say bigger for me even than like neovim versus VS Code. Like you can be really fast in VS Code. There's people that are really fast in VS Code. The thing for me that's kind of the deal, like the deal sealer, is that just living in the terminal the whole time. So like using neovim in conjunction with something like Zellige, where I can like do crazy terminal things that you just can't do in VS Code, obviously, and like splitting and splitting and splitting and splitting and just like having a bunch of terminals open like that, to me, is what makes neovim really good. Just having it live always in the terminal is super good. Because I kind of try to use the terminal for as much as I can, always. Okay, so what were we doing? Oh yeah, we don't need a negative prefix operator, right? So I'm going to how do we do this? Oh yeah, tokens. No, not tokens. AST, right? We should have like a prefix operator. Prefix operator? It's logical. We still have logical not, but we're not gonna have negative. We just have that. So that broke this. That's fine. Minus is no longer a prefix parse function. And this no longer does that. Okay, that's cool. So that means we need to change our test, right? Operators, we just have 9. That's really our only prefix now. Okay, so now let's try that again. It failed. No prefix parse function for minus. Am I using that somewhere? Oh, I am using it here. Okay. It failed again. No prefix parse function for minus. Where am I using it as a prefix? Oh, here. There we go. Okay. So now this is the operators one, isn't it? Operators, yeah, okay. So we have a bunch of expressions. This is a list of expressions. This one is a prefix expression, perfect, which is a logical not, exactly, and it's nodding true, which should give you false. We have an infix one, where the left is an expression, it's a block expression, which is an expression, which is an infix expression. Oh dear, this is getting a little hard to read, which is an int. It's a block. The left side is a block. Which is an infix. The left is a 3, and it's minus with a 4. So that's this. The whole thing is multiplied by 2. So that's this entire thing. Then we have another expression here. It's even more complicated. It's an infix, right? So the infix would be this minus here. It should be. The left is an expression, which is another infix. The left of which is another expression, which is a block, which has an expression in it, which is another block. Perfect. So that's the nested block here, which is an expression which is an int literal 3. Perfect. And then it's divided by exactly an expression, which is an int literal 7. That entire thing is subtracted from, it is being subtracted another expression, which is an int literal 22, exactly. Then we have another expression, which is infix. It's 3 is less than 5. Perfect. And then we have another one, which is 6 is greater than 2. Perfect. And then we have 3 is less than or equal to 5. Perfect. I always struggled using the default debug format for AST. It's super noisy. Yeah, for sure. I thought about making a custom one. But for now it's been all right. But yeah, I think I'll probably long term make a custom one. How does your lang named, and are they some specific cases why you need a new lang, or just for fun and education? Just, yeah, fun and education. You mean like what's the name of the language? It's Lovely is the name. What is this? 6 greater than or equal to 2. Perfect. All right, and then we have 3 equal to 5. Yep, and then 3 not equal to 5. Perfect. So that worked. Accept that. Oh, and then I removed some things here. Okay, so that's fine. We can accept those ones. Here's another one from primitive literals. We have an expression, it's just 0. We have another one that's this big number. We have another one that's true. We have another one that's false. We have another one's unit. That's all it is. Okay. Accept that one. All right, and then we have another one that is variable decals. So here we have a variable decal. It's binding foo to 6, and it's not mutable. Perfect. We have another one that's binding bar to 7, and it is mutable. Perfect. We have another one that's baz, which we're binding to true, and it is mutable, and the type is an identifier bool. Perfect. Here's another one. I don't even know how to say that, which is of type unit, and it's bound to unit. That's perfect. Sweet. So the parser's working, folks. This is great. Okay. So that means we can get back to type checking. What about the star operator? Like, are we not testing that anywhere? We're testing that right here. It worked. Looked into various SerDes output formats and as an alternative, but didn't find anything suitable. Yeah, I feel like I ended up just making like a custom display implementation. Wouldn't that work pretty well? As opposed to using SerDes. How did you come up with a name? I'm struggling to find one, and Lovely is pretty good. I have no idea how I came up with Lovely. I think that was just like my condition for the language is that I wanted something that was going to be lovely, and I was like, oh, Lovely, that'd be a good name. It's probably just kind of lucky. I'm not very good at naming things either. Although I want to name something Odoo sometime. Odoo, wouldn't that be a good name? Oh, star as a prefix operator? Oh, you mean for pointer dereferencing? Good point. Well, I think we'll just tack that on when we get to pointer dereferencing. It's really easy to add tokens. And the question. We're not using question for anything, are we? I don't think we use questions. You can always ask Mr. Glick, you can always ask our friend AI for like names. I'm making a programming language. What's a short, memorable name? Fun I don't know, whatever you want. Name. Zap. They're usually pretty bad. Like, these are pretty bad. Something more unique. But I didn't do this for, yeah, like Plinkett. That's cute. I didn't do this for lovely. Quarble? Quarble. That'd be a fun one. Alright, anyway, so that's all good. So let's go back to our checker now. Which everything is commented out. Wow, we did a lot on our checker. I didn't realize it was so much. Gee whiz. Who knew? Alright, I think there's errors. I can't even see them. There we go. Yes, this comes down to the fact that T is a scope type. Yeah, so we changed the scope types because now they have a kind, which can be a name, like a named one, or it can be function one, which has a parameter or return type. We don't have a means of parsing function types either. That's okay though. I don't think we need to yet. Parameters are vec of scope type. Is that correct? That is correct. Well, no. Look, we need to have this struct function parameter type, right? Because it needs to have a kind, which is a function parameter type kind. Boy, I can't wait until we have product and some types and one type and lovely, because this will be so nice. I'll never have to do this again. I'll never have to do type kind again, this kind of thing. You can just have type kind, and then, yeah. You just have the variance right in here, and then attributes. That'll be so cool. Okay. Kind. The kind would be oh, sorry, I missed some chat. I'll call mine learnable. That sounds great. You can do custom display, but then have to deal with indentation and writing the whole recursive traversal thing. Ooh. Truth. What's wrong with lovely? Robin. Hey, Robin, first of all. Second of all, there's nothing wrong with lovely. I think he was, somebody was asking about what to name their language, like how I came up with lovely, because the name is good. Lovely's fine. Toml X, there you go. At what age did you start coding? I started coding at like 12-ish or something. Yeah, Mr. Glick asked. We're sticking. Lovely's a good name. We're doing that, but. All right. So function parameter types have a kind and a type, which is just a type, right? A scoped type. Yeah. So parameters are the vec of function parameter types. Function parameter type kind, enum function parameter type kind. What a nice name. This should go up here. It's time to clean this up a little bit. And then, yeah, so these, because the reason I have this, okay, so these function parameter types can be, they can be, okay, they can be owned. They can be read-only refs, or they can be immutable refs, right? Okay, so that works. What's my type system based on? It's based on how much I hate having to do this. Like, isn't it annoying that I have to... Like, this needs to have a kind on it. So I have to make a separate enum that is linked here. That's here. Then it has this nested thing that I have to name here. This nested thing has another kind associated with it, which has to be another enum, right? So it's like I'm like 4 types deep by the time I get here. And lovely, literally all 4 of these types can be like expressed as one type. I don't know if that'd be the best way to do it, but they could be. Because there's not such a strong, there's no distinction between product types and sum types, right? They're like, you can have the same thing in both. So that's kind of what my type system is based on, and lovely. So yeah, okay, so that should work. We'll go over to here now. So at this point, check type name takes a type, right? Check type name isn't really good. Oh. Yes. There should be something like lookup type. I think this is what it was named before actually, and then we renamed it. All right, so lookup type needs to match on type, I think. Already have that, so we just have a name. So all we have is a name here, because there's only one case for this thing, right? Which is why we can do this. Yeah, honestly, lovely type sounds so good. Or maybe I'm just feature deprived because I write C. No, I write Rust and Swift all the time, and they're kind of, and I've learned OCaml to some extent, and those 3 languages are like especially known for their amazing type systems, which is kind of why I learned them. And they have the same issues, so I don't think it's just a C thing. So hopefully people like it. I don't know. Okay. What do we do here? So this is types is a vec of. Hey, is this global thing an allocator? Does some Rust nerd out there? It is kind of just syntax sugar though at the end of the day. I don't know if it's syntax sugar. Yeah, it's the global allocator. Okay, thank you. I feel like it's a little bit more of a deeper concept than just syntax sugar. You're kind of just erasing the idea that structs and enums are 2 totally different things. You're just saying, no, there's just one thing. Right? I don't know if I'd call that syntax sugar. It's syntax sugar maybe in the sense that you could express it the other way with structs and enums, but it just would be a lot more verbose. Okay. I kind of have to. How can I do this? It's functionally the same as having a product of a struct and an enum, just less verbose. Yeah. Yeah. So the scope ID is the same, and the name. So there's not necessarily a name on these things. Okay, so I think I need to make this closure be a little more chunky. Just the moral of the story. So T here is a scoped type. Match on T is kind of what I need to do here, I think. Oops. Oh. That's what I meant. Now I should be able to do this. Okay, there we go. If we have this, oops. How do we do that? If we have a name, oh, this is gonna conflict with that. What was, oops, that's no good. It needs to be in the same scope, right? By the way, will the language have any way to call external functions, such as functions from shared libraries or a function added from code as a definition? You mean from other languages or from itself? I'm not sure I totally understand. Wait, cur scope here is a scope. Oh yeah, this is no good. Wait, what was that other check I had here before? T.scope ID equals scope ID. Oh. That's what it was. Help. What in the world happened? Okay. There we go. That should do the trick. Okay. So then check expression statement is no longer a concept. check program. Check program just has expressions now. Back check expressions. There's no check expression statement. Okay, check expression statement. Yeah. No type hint on those, and then this can be called E maybe because it's expression. Check expression has some issues. Block not covered. Negative isn't a thing anymore. This can be a to-do. This is for function, right? Okay. So this should be checked instead of checked expression statements from other languages. Yeah, so you mean like C interop and stuff like that. Potentially. I feel like the language I would be most motivated to make it like interop with would be Rust. I just have no idea what that would even entail. So definitely not at first, but potentially yes, that would be pretty motivating for me. On the feature wish list, we want to have inline ASM, so that's one thing, sort of similar, but not exactly. So check expression. This becomes oops E, none, and E. Body's no longer a thing. Wait. You don't need to do that. Wait. Let body equals self dot check, because now we just have an expression, right? Which would be, do we have a body in here? Wait, so we could literally just check the expression. It takes an optional type hint. We just type hint it with the return. Statement, couldn't we? With the return type? That's perfect. So the type hint for the function body just becomes the return type. And then that can error, so we'll do this. What is on this thing? Data and type ID? Okay. Wait, what's the data? Oh, yeah. What language are you using? Yep, this is Rust. And this becomes the body. right? Oh, I don't think we have to do this check anymore because we're checking it here. So yeah, we'll just do that. The body just becomes the body. Type hint to do function types. So we need a type now. Yes. You want to learn React and TypeScript? Any advice? I don't know that I have any like really good resources. I saw didn't they just come out with like a really good new or supposedly really good new React course? React.gg. This just came out, or maybe it's coming out in 2 days, I guess. Or no, there's a launch sale. Hey, check it out, 30% off if you get this in the next 2 days. I hear it's pretty good. It looks pretty fun. TypeScript? I don't really know. Yeah, I can't say that I have like great learning resources. Other than like my advice would just be to actually build something like as soon as you can, as opposed to just reading a lot and watching a lot. So, because that's definitely how I learn a lot. Okay, so this function types is where it gets a little bit tricky. All right, when we have a function, we kind of need to like Well, in all truth, I kind of just want to make sure. You're already learning by doing? Awesome, yeah, that's great. All right, I just want to make sure everything else works before I start working about these function types, because this would be like the new thing. I don't even know if the old stuff works, so. Checked expression statement. Oh yeah, see, this is no good. Checked expression data. All right, so there's some to-dos in there, but let's check this. There should be. Oh. It's because we're not actually doing it. Okay. Not yet implemented. Oh, we didn't do the block expression one. That's easy enough. Reset a block case here. That looks like that, right? A block is just a vec of checked expressions. And then the type ends up being the type of the last expression, right? So finally got home and you have audio now. Awesome, cool. So now we can do this. How long it takes you to type fastly without looking at the keyboard? Oof, I really don't remember. I've been typing for a long time, so I remember doing like some typing tutorials and games and stuff initially to like learn it faster. I really don't know how long it took. Like it depends where you're starting from too. Like, are you not at all able to type, or are you able to type slowly, or are you able to type fastly if you look, or I don't know. If you just do it a lot and try not to look, right, then it should, I don't think it would take super long. Experts. So we're just going to say, oops. Oh, not this one, not this one. This one, there we go. You notice people who use Vim type faster than average. That's probably true. Because it's partly because it's probably people that are interested in like productivity in general, and partly because, well, yeah, I don't know if it necessarily makes you type faster to use Vim. Well, the point isn't that you type faster. Like if I'm just typing a sentence, like, hi, my name is Micaiah, like that doesn't actually, I can't type any faster in Vim than I could in VS Code. But like with fewer keystrokes, I can do more things. But yeah, the kind of people that use Vim are the kind of people who, what's my words per minute? Let's find out. It's not anything crazy. Monkey type. That's fine. Wait, how do you do this? Turn when time. 15 seconds. Ready? Here we go. Wait, I need to make a new window. Okay, hang on. Whew, gotta warm up. That was pretty bad. So I was fixing mistakes. Tab plus enter. Hold on. Stop. Bad start. Okay. Hold on, I hit tab. Oops. Ugh. Yeah. I guess it's not as good as I thought. 93. But that was only at 93% accuracy. Depends what you're typing, dude, because I'm usually not just typing English. I'm usually typing stuff like this. Started coding like 10 months ago, and I learned HTML, CSS, JS, Vue, PHP, Laravel, SQL, REST API, Git, Linux. Good griefers, that's a lot for 10 months. Been typing their whole life and still don't touch type. Guess it depends on the person for sure. Surprised some people haven't just started coding on stenographs. What is that? Nice, you're like 75. Yeah. Okay, so I need to oh, this needs to be Shucks, why can't I do this in a closure? I guess I can do this the imperative way, right? So you guys here are already done with learning. No way. Do you see what I'm doing here? This is all for learning. So now we have checked expressions. That's cool. What do we do with them exactly? I also have no type hint. Okay, so there's no type hint for all of them except for the last one, right? Okay, the last one needs to be type hinted. My UI is nice. How did you get that? What UI? You mean Neovim and Zellige and stuff? Like my terminal UI? Oh, you're talking about the chat? What, you mean just how the chat is up here in the corner? And how I'm down here? Is that what you're talking about? Okay, so we have these checked expressions. What do we do with them? So check the last one, right? So color scheme and stuff for Neovim. This is Everforest is the color theme. So let's do Can I do this? Now we have perfect. Okay, so then we can say that, right? Perfect. Okay. So then if gotta go. All right, see ya. If the index that's not right, right? The index would be -1. Do the same thing, except for this one should be type hint. Right, the last one has to be the same type as what we're expecting. Cool, so then what? We have this, and we should be able to do this. I think. This needs to be like that, and that needs to be like that. Span. Ooh, good point. Well, expand should be able to be expert span. Res type should be okay. I'm gonna do this. Let checked expert equals self dot check. No. So this now is a checked expression. We don't need to do this in, well, checked expert dot push checked expert. And then we should be able to also say like the unit ID maybe, and then if it's the last one, then we're gonna say equals checked expert dot type ID. So now we have the type of the whole thing too right here. So the res type becomes the type ID, and that should be the same as the type pen. All right, so that should work for blocks, I'm thinking. Are you doing this just for the understanding of what goes into creating a programming language? Sort of. I'd like to use it though too, if possible. Let's try this test. Oh, sweet. Okay, check it out. idents. Okay, idents. Idents. Okay, so we have a checked expression. It's a variable decal. The type of ID is 2. The type 2 is 2 is a unit. Somebody was suggesting we just use an enum for these, but then you couldn't add new ones. Yeah, so that doesn't make any sense. So 2 is a unit. So because this whole entire thing ends up being a unit, right? We are assigning a to a number 12, which the type is 0, which is for ints, and it's mutable. Perfect. Variable ID is 0. Then we're making another one, which we're assigning b to 9. Type is int again. Variable ID is 1. Then we have another one, which we're assigning c to an infix plus of a and b, which are 0 and 1. It's referring to 0 and 1, which we made right here. Perfect. So we're making a new variable, which is variable ID 2. Here, and then here's the magic. We have c here. We never anywhere specified that c was an int type, and we don't know, like, these aren't int literals, right? So we can't infer it from that. We're only using the history that we know that these are. So right here, c is of type 0, which is an int type, and the variable ID is 2 because it's referring to this guy. Perfect. That's super cool. So that's all good. What problem are you trying to solve with a programming language that you find others don't do very well? A handful of little things. Just like, I'm mostly doing it just because I want to make a language, right? And so it's not like I have some giant overarching thing. There's just some like little nice things that I kind of want. One of the bigger like type level things is that I'm kind of removing the huge distinction there is between like product and some types, and I'm making that kind of into one unified concept. All right, what one is this? This is operators. So we have a checked expression. The type ID is 1, which is for booleans. It's a logical not prefix with a bool literal. Perfect. Then we have another one. Checked expression. Block expression. The expression is perfect. That's good. Another checked expression. Doubly nested block. Right? It should be block and block. Yep. Perfect. Another one. These are all the simple ones. Sweet, that totally worked. And then what one is this one? This is a simpler one, obviously. Primitive literals. We got 0 is of type 0. These are all, the numbers are all type 0. 1, that's type 0. Bools are type 1, 1, and the unit is type 2. Perfect. And then this one is variable decals. Foo gets assigned to 6. The type is 0. Perfect. Bar gets assigned to 7. Type is also 0. Baz has a type of 1, assigned to true. And this is a type of 2, which is unit, assigned to unit. Perfect. That's all great. So that's all working again. Let's just get functions working now. Why is type ID not an enum? Because then I couldn't add, you can't like add new cases to an enum after the fact, right? And I need to be able to add new types to my type definition array. So I can't just add enum cases. For someone who has only experience in programming in HTML, what do you mean? Oosh. It's sort of hard to explain unless you're familiar with a programming language. Do you know like JavaScript or anything? Although JavaScript doesn't have types either, so that kind of makes it hard. Basically, a sum type is like a variable that can be this type or this type or this type. It's like one or the other, not both, right? A product type is something where you have one variable that has various, simultaneously has various different attributes or qualities or fields or whatever you want to call them, right? And there's like this huge divide between those two things in most languages. And I'm sort of removing that divide. So I'm saying something can have a variant and also have attributes at the same time, if that makes sense. Back from dinner, what do we have now? We're basically back to the type checker working exactly like it was at its prime. And now we just have to go continue and add the new stuff. Is that a pipe at the beginning or just editor stuff? This pipe? You mean these yellow ones or these blue ones? Both of them are just editor stuff. The blue ones mean I changed this line because it used to look like that. It's just like get stuff. Hash non-exhaustive. Wait, does that let you add cases to an enum? The name sum and product comes from the amount of possible states they could be in. Yep. Oof, you guys moved the syntax a lot. I was afraid for a moment. No, it actually came together really easily. Part of that was that we're not really parsing much of the stuff that we changed the syntax for, and so it was mostly a matter of like removing semicolons and adding like arrows and colons to function things, which is fine. Did you think about const expr and const eval? No, I didn't really think about that. Like comp time evaluation, I feel like that'd be like a very much a later thing I think about. I'm trying to just think about like what's immediately at hand. All right, I'm gonna keep going for a little while more, but before I do, I'm gonna get some more water and run to the bathroom. So I'll be back in 3.5 minutes. Okay. I'm gonna stand up now. What are you guys talking about? Some in product also have more general definitions in set theory than category theory, etc. The cardinality thing is just an analogy, I think. If it is just an analogy, it's at least a very good analogy. Like it definitely works that way too. Well, this guy, wait. So this guy's making unionized tuples. What would a unionized tuple be? I'm using NixOS. I'm slowly understanding programming better. I should tell that I use AI to help me because I can store all that info in one place, so I don't have to score the net for answers. Fair enough. You tried. I'll wait. Unionized. That is poetic. Okay. Anyway, let's keep going here. So I wanted to make a test case real quick for block expressions. So block expressions would be a good test case. So if we have something like such a wordsmith. If we have something like foo, or we'll call it x, right? X is a block expression, right? And make it equal to say we had something like unit and then true and then 7 minus 4. This should be an int, and then if I say x down here, right? So just a simple case like that. Let's test it. This is just a pointer to name new concepts. I'll come to you next time. All right, so here's the, well, we know we can parse this thing, right? Okay, so that's good. All right, here's the checked thing. This is what I'm really interested in. All right, we have an expression. It's a checked expression. It's a variable declaration. We're binding x to another expression, which is a block expression. The expressions are as follows. We have, oh, by the way, the type ID is 0, which already looks really promising because that's the type for an int. The first expression is a unit. The second one is a bool. This next one is an int, right? The entire thing is bound to a variable, which is 0, and then we're referencing that same variable 0 here with a type of 0, which is number. So it knows that this is a number. This is lovely. We know we can tokenize it. You know what's interesting is if I did something like this. If I said, now, if I typed this wrong, like if I try to say that this is a bool, actually, I don't even know if we're checking stuff like this, are we? No, we are. If I try to say that this is, right? Yeah. If I try to say that this is a bool now, is it a boop? Type mismatch, expected 1 got 0, which is perfect. That's saying expected bool got int, right? It's because I said it was a bool, but it became an int. That's so cool. But if I said this is an int, then it's cool. We just added some extra information to some stuff, but otherwise it's good. But I don't want to add any type hints. I just want it to drive me. Oh, you know what would be a nice thing to check is if I did this. Y int should be x. That should work. That'd be a good test. This is the parser. That's fine. Here's the checked expression. So we're saying we're binding y now to our x, which is an int, and the whole thing. Okay, that's good. And we can tokenize it. Okay, cool. I'm going to commit here. Yeah, okay. Revise new syntax a bit and got checker back to working for basic stuff. push origin master. Yeah, that should be up to date. Are you making this self-compiling? What do you mean by self-compiling? What does it mean to be self-compiling? Cool. Let's work on some functions, right? So let's go to test. Let's make a function one. Source files. Okay, functions dot lovely. Hello and bye. Hey cat. You use your compile, just like self-hosted? Like bootstrapped? Not right now. I mean, obviously not right now, but long term, yeah, that'd be great. I think we should do that. It'd also be great for like dog feeding it. I'm gonna say make add be a pretty basic function. The one we always use for an example, we'll say x is an int, y is an int. Sorry. 2y is an int, and it returns an int, and it returns x plus y. How about that? So this, I'm not sure what it's gonna do. We're gonna find out. What would it do? Cargo insta-test. It not yet implemented. That's good. To do function. Yeah, okay. Would take a while to do that, but would be pretty cool for sure. All right, so that's no good. We're gonna keep using this one. I have a feeling this is gonna get somewhat hairy. Whoops. So let me just walk through what we're doing here real quick. So we're creating a new scope. We say new scope, self.create scope, and then we move into this new scope by saying the current scope to this new scope. Then we initialize some checked params, and then we loop through the params and we check them, I guess. Although I just realized that params. This is gonna get really complicated because this is where the whole borrow checker thing is gonna come into play. Although the rules are rather simple. I feel like it's actually going to be sort of easy to implement. All right, well anyway, we're kind of ignoring that for now. So we make check params, or should we ignore that for now? Ooh, this is kind of hard. Hard enough that I need to take off my hoodie. Okay. What do we want to do here? Should I start worrying about the borrow checker? I think I probably should. Yeah, let's do it. So, all right, AST. Is this language going to have the same borrow checker thing like Rust? It's very similar. It's going to be basically like Mojo's. Okay, wait, do we have... Right, so functions look like this, right? They take things like this, but there's in here... So variables need to have a concept of whether they're, oh, they already have a concept of whether they're mutable. So I wonder if maybe variables should just have a concept of this is interesting. Okay, so every variable should have a piece of information attached. Or like right now, a variable just says it's either mutable or immutable. That's not everything, right? Because of this whole borrowing system. And so a variable is really either mutably owned, mutably borrowed, or immutably borrowed, right? So we kind of need to extend that a smidge. Correct? Okay. So let's go to the AST because that needs to live on, well, does it live on here? It doesn't really need to live on here. No, it doesn't live on the AST. It would live in the type checker. Yeah, so I have that like scoped variable. Scoped variable. Okay, so variable. Scope variables have names, types, the scope it lives in, that's perfect. But then I need it also to have like a borrow status. I don't know. Borrow checker, borrow status. Borrow stat. Anybody have a better name than borrow status? It's either mutably, oh sorry, that's not how this worked. Mutably owned, or I could just say that sounds really interesting, hyperbanner shell. Well, I could either make this an enum like this, or I could just have like two fields, like mutable and owned. No, I think enum would be nicer. Pub struct, no, pub enum, borrow status. It's going to be I think that's kind of unique as a first personal project. Yeah, for sure. That's really interesting. Whoa, I just like locked my desk. That's kind of cool. So okay, yeah. So mutably owned, immutably owned, mutably borrowed, or immutably borrowed. Sounds good, right? And then this will just take a borrow status, which is a borrow status. And that'll just pass it along here. Okay. So now every variable has a borrow status. You plan on calling it hush? Hyper is useless shell. That's great. I love that. Hush. You really are a wordsmith. All right, so now that kind of works. Well, obviously it doesn't work, but the concept is good. So when you add a variable, yo, what shell do you be using now? And then you say hush. Yeah, that's good. Add variable. So I guess I should just take a var name, var type in the current scope. Yeah, I should take a borrow status, which is a borrow status. And this should be in here. You know, what I don't really like is that these are all from this like scopes thing. This isn't really right. This should be, there should be like a variables and a types, I think. Let's do that. Variables, or I'll just call it vars.rs and types.rs. And then in here, instead of mod scopes, I'm gonna do mod vars and mod types. And then I'm going to take everything, oh wait, we do have scope. See, scope can be a concept that lives in, scope can live in here. That's fine. And then, and a scoped all this stuff goes in vars. Type ID. Yep. And that. And now we're good. And then the type stuff will go in here. Very good. Okay. And then scopes is useless now. We don't any longer need that. Now we got a ton of errors. Scope types comes from there. This comes from here. This comes from here. This comes from here. Add variable. Yeah, okay, so wherever we're using all right, so here, where is this? In a variable declaration? So whether or not it's mutable. So this is if you're like declaring a new variable, so you always own it, right? So it's gonna be owned, but it depends on whether it's mutable. So if mutable, else. So borrow status, mutably owned, else borrow status immutably owned, right? Why can't you? Oh. Okay, that's cool. And then add variable here. Where is this? In a function? Yeah. So this depends on, ooh. Okay, so function parameters need to glow up, right? So yes, they have these two cases, but they can also have, I'm wondering if I should not have these two cases. Kind of makes things complicated, right? All right, so I feel like I should just have, the programming language is called Lovely. Okay, so I'm gonna do this. I'm gonna get rid of this. Right, this is just gonna be struct. It does have a type, it has a name, and then I'm gonna have an optional call sign name. Ooh. Yeah. I'll also have unlabeled. Well, no, it really should be an enum, because those two things are like unacceptable. Okay, yeah. So enum is good. Enum is good because we need to make it impossible to represent impossible cases. So type external name, external name. I'm gonna say parameter modifier. Hey, Lord Pyjo, that's not very nice. It can be either sorry, my mind is like just totally blanking. This needs to be read mut. Okay, so read mut or out, right? What is it? No, it's read mut or take, right? Yes. Okay. So then read mut or take. We'll do modifier is a parameter modifier here and here. We could make it option. Should we make it optional? See, because if you don't have one, it makes it read. Do you think we should just fill in the read here? Or at what point do we do that? I think it'd be easier just to fill it in here. So we always have a parameter modifier we get to this point. So here we have a modifier then. And here you'd also have a modifier. Yeah. Okay, so then go to our parser. By the way, did we ever deal with shadowing? No, we didn't. Yeah, okay. We did do this. That doesn't really make any sense anymore. Okay. So we need to be parsing. All right, so I'm going to say this. I'm going to say let mut modifier equal parameter modifier read is the default, right? We have a modifier, and then I'm going to do this match self dot p kind whoa there. We don't need all those. Basically, if it says mutt, do something. If it says own, no, it says take, right? Then we're gonna do something. Otherwise, we're not really gonna do anything. Oh. Mutt. So if it's mutt, we just say modifier equals parameter modifier mutt. Here we'll say modifier equals parameter modifier read. And then otherwise, we do nothing. We also want to, okay, we also want to consume it, right? Here we'll expect a, sorry, not read, this should be take. This should be take. If it's read, by the way, then we don't have to change anything here because it's read by default, but we should still expect the read. Otherwise, we just continue. And then we can say modifier becomes that guy. And modifier here becomes that guy. So now we should be parsing those things good. It's pretty easy. And then, cool. So let's jump over to here now. So in here, we need to add a variable. This is in the function definition, right? So we look at the parameters. You look at the modifier, right? So the modifier would be it'd be this, right? Match modifier and then get rid of this. If it's read, so okay, if you get a read thing, then we'll have a borrow status immutably borrowed, right? If it's mutt, okay, a borrow status mutably borrowed. If it's take, then wait, if you have an own parameter, you can't mutate it, right? Yeah, I think so. Immutably owned. We're literally going to do the same thing right here. It's a little bit duplicaty. That's all right though. All right, there's that, and then yeah, what's next? What's that other error sitting around? What is this? Return type. Get the body. Body's a checked expression. Box. You gotta box the body. And then that we don't need. All right, and then it's just a matter of the function type. So when we use this function, we need to sort of create a new function type. So function expressions still, they kind of implicitly define a new type, don't they? I think that's what it'd be. I think that's what it is. So do we have like a add type? What message do we have on this thing? Create scope, lookup type, check variable name, add variable. Okay. Lookup type. So let's make a this should be lookup variable. All right, and then we'll have add type. I feel like we almost need to pass just a type kind, right? Probably. And then it'll add a scope to it. Yeah. Kind will be a type kind. And it'll return its ID. Type ID. And it's going to do something very similar to this. Let me just almost copy this and then type ID equals self dot types, and then self dot types dot push scoped scoped type. The kind is just the kind, and the scope ID is like self.cur scope, which isn't a function. This would need to be mut self. Okay, so now we can add a type. And now in this function thing, we need to add a type. Create a new scope. We'll do that down here at the end, right? So we have a return type ID and stuff. Okay. Let type equal add type type kind function parameters. Okay. function parameter types, and return type. The return type is just a scoped type. Does the return type need to be scoped? Okay, I think a lookup type should maybe return the scope, like what scope it finds in the type. Although, you look up a type in a scope. But that's not necessarily the scope you find it in. Ooh, this is interesting. Okay, so type ID. So let's do this. Scope. Scope. That's not how this works. Type ID. Scope ID. It'll be the scope. This will be the scope you find it in, right? Because if you find, sorry for kind of derailing chat, no worries. Type ID should be unique across scopes. What do you mean by that? Unique across scopes? I'm a little bit confused right now. Like this return type needs to be a scoped type. Like you can potentially look up the defining scope just by the type ID. Yes. But the scope ID, oh yeah, I think I got this. Okay, so the lookup type, the scope ID is just like the scope you're looking for it in, right? So that's what that is. But the scope you found it in is what you should return. Parameter scope ID is the scope to look in. Return type scope ID is the scope it was found in. Look. All right, that should help me out a little bit. Now I get this nice documentation here in LSP. What theme are you using? This is called Everforest. So we'll just return the scope ID here. Like that. Ultimately, this should probably do the same thing. Oops. And then okay, this makes this a little bit tricky. Actually, this. Oh. That works. Oh, that works. Or better yet would be just to get rid of all of this. And do this. There we go. Okay, so now except I kind of do want okay, perfect. So then I can oh, wait. I don't think I needed to do that. Because can't I just do... that? Nope. Wait, what? Oh. Oh, shucks. Okay, so I didn't need to do any of that. Change plans. Whoops. And here too, really. Alright, that should give me plenty of bugs to fix. and then that's the real one. Okay, sweet, so that wasn't actually too bad. So then the parameters are this, right? That would be a vec of this. Okay, so where are my parameters? What? Kind needs, so what is it? What's on this P? This is rather complicated. I thought these had modifiers. Oh no, they don't. Trying to get a kind. I wonder if I could do something like, oh yes, now I just have a modifier. What are you working on now? I'm working on type checking function expressions. So what is the type of kind here? Function parameter type kind. So if it's read, if it's read, it's a read-only ref. If it's mut, it's a mutable ref. And if it's take, it's an owned. The type is, oh, these both have a modifier type ID, don't they? Wait. Oh dear, I gotta do the match dance again. Okay. Um, hmm. This should be a reference. No? That needs a lifetime parameter. Anybody have any thoughts on this? These things hold on to scoped types, but they really should be references. Same with this one. Um, the alternative is cloning. Scope type. This is really bad. This whole chunk is really ugly, and I'm doing clones. All right, maybe let's make this out of to do. To refactor this. Super ugly, and uses .clone twice. With references, you would have a self-reference problem, probably. Would maybe need to work with indices or something. Yeah, I don't really know what would be good here. All right, well, it'll be fine for now. Just in theory, it might not be very performant, but that's probably fine. What does that even give us, what we're trying to do here? That literally just gives us, oh, that's the type. Okay, that's good. Which goes here. So maybe that works. I don't know. No. Parameter modifier. This thing can be clone, copy. That's good. Okay, so okay, so it's doing something. Let's check it. So it's this function one is a new one, right? Let's see what it does. What is this? This is just the AST. Let's check the AST. So it's an expression. It's a variable declaration. We're assigning add to another expression, which is a function expression. So far, so good. The parameters, here's the first one. The first one is unlabeled at the call site because it has the tilde. Its name is X. It's got a read modifier because nothing was specified, which is perfect. And its type is int. Perfect. The next one is labeled at the call site. Yeah. The internal name is Y, but the external name is 2. The modifier is also read, and the type is ident. Sorry, an ident of int. The return type is int. The body this is an expression. That's an infix expression. The left hand side is X, and the right hand side is Y. It is immutable, and the type was not specified. Okay, perfect. Now here is the checked version. So this is what I'm really interested in seeing. So expressions, the checked expression. Type ID is 2, meaning this whole entire thing evaluates to unit, like the entire variable declaration, which is what we expect. The name is add, which is great. The value is a checked expression. Type ID is 3, meaning we added a new type, which is this anonymous function type that we're not actually using anywhere. The data, before I do this, I want to make a better test. I want to reference add down here. So we added to the AST just another expression down here, which is ident add, which is good. All right, and then here's this. So checked expression, it's a function, type ID 3. A programming language as easy as a kid in school can understand and learn. Yeah, I don't think this one would be particularly complicated. Parameters, all right, we have unlabeled at call site. Wait. Yeah, unlabeled at call site. These are kind of the same. The type ID, except for the type ID is 0 for both of them, right? So that's good. Which is because that means int. The return type is also 0 because it returns an int. And then the body type ID 0, which is good. It's an int. It's an infix. It's a plus from X, which is a variable ID 0. This one is variable ID 1, which is interesting. That does make sense though. Is it mutable? No. Variable ID is 2. So, oh, that's really super interesting. Okay, so this ends up being variable ID 1. This ends up being variable ID 2. This ends up being 0, 1. This is 2. And then we reference it down here. Type ID is 3, so it's referencing the same type. So this is working perfectly. Variable ID is 2, exactly. The name is add. That's so cool. Git add dot git commit dash im type checking function expressions. Now we haven't really done borrow checking yet, but we're pretty much all set up for it because we know all the information about like the rules of our variables as they come into the function. So it would just be a matter of dealing with them in the right way. That was really cool. So next thing would maybe be like function calls. Yeah, but before that is going to be another bathroom break. I'll be right back. Okay. This is so inspiring. Randomly found you through YouTube recommended, and I already want to work on my own thing again. Awesome. That's so cool. Super glad. I love to see your lang. Is it open source? Sababugs. So memory management is on via checking. Yeah, pretty much. So like, there's sort of currently there's like 3 schools of thought. It's like, well, there's like 3 things you want to avoid, right? It's like double free, use after free, and memory leaks, right? Those are kind of like the things that you're trying to avoid, right? And so to avoid those, either you just trust the programmer to avoid those, which is what like C and C++ and Odin and Jai and Zig all have you do. You can have a garbage collector or like a reference counter or something, and then the program or the language just does that all for you, and so you don't have to worry about it. And that's like all most higher level languages like Go and JavaScript and Ruby and whatever. And then there's the third camp, which is pretty much just like Rust and Mojo, as far as I know, but there might be more, which is say we're just going to make it impossible for you to do those 3 things. We're not going to take care of it ourselves, but we're going to make sure that you can't do it. We're just going to enforce it. And so that's kind of what the borrow checker does. So yes, I'm going with the third camp, just making that impossible to do. And so those are the memory safe languages, right? Okay, so we just type checked. Did I push to GitHub, by the way? No, I didn't. There we go. Now I did. Let's check that out. Where's my browser? This one. Joink. My spike isn't doing so well. It kind of dropped. But yeah, we had what's this 2 here? I have no idea what this is. It's this guy. Okay. Now there shouldn't be a 2. Thank you. We go checker. It should all be here. Where's the ugly part? This is the ugly part. This thing. Cool. So yeah, what should we do? Memory leaks are technically safe. Rust does allow for them. Yes, sort of, right? But isn't it kind of a little bit different? Okay, so I mean the next obvious thing would be, because if we go into our, there's that to do. Okay, there's also that. Wait, what was this one? Lookup types. Oh, because we're not really referencing function types yet. That's fine. So this to do would be function calls, right? So let's just do function calls. Add. And then as soon as we can do function calls, I want to start generating assembly. How about that? We're going to do function calls, and then we're going to start writing assembly so we can actually run lovely code. Any objections? Any objections? And then that's fun because we get to start working on the CLI and all that kind of stuff. So that'll be lots of fun. So I'm just going to do this. Add 4, 2, 9. This should give us 13. And I'm going to bind this to some variable. And then here, I want to reference x. So this is a pretty good test, right? I think so. Okay, so let's, oh, I forgot to do this. Yeah, there we go. Okay. Here's our test case. Let's, if we were to do this right now, we should get a to do. Yeah. To do, not yet implemented. Cool. Hi, Tez. All right, let's run in here. We'll just try to do this. The function call. It's just, yeah, this is a little bit interesting. So, function and function call. So let's open up AST and then, are you going to be adding pointers and addressing? Yeah, we already have syntax for it. But like pointer dereferencing is an unsafe thing, so you have to do it in an unsafe block. Where is this? This guy, function call. So it kind of looks like this is usually what we start with. Function call. Oops. Has a name, sure, function argument, and then this, what does this look like? We'll have like a checked. Checked function argument. Keep going. I really love low level on what you do. I'm trying to. Appreciate it. So this will be a checked function argument. Cool. Oh, which is a label, the values, and expression. A checked expression. Wait, no IR? You mean like no LLVM IR? Because this is kind of like my IR right here, sort of. Oh, these don't need to be pub. Just need to be pub? Who's pub in here? Oh, that needs to be pub. Okay. Yeah, no, I'm not using LLVM or anything. I'm generating assembly myself. Is that what you're asking? Cool. So we'll do that, I guess. Checked expression. We just need to check against the type of the function. Okay, well, this will be interesting. So, where's our to do? This one. Okay, so what do we have in here? See what they give us. Just name and arguments. Okay, so we will return at the end of the day, we want to return a self.typed expression. There should be a checked expression data function call. Takes name and argument. So name just gets passed along. This becomes expert.span. This becomes a to do. And this can be typed in. we go. Arguments. So this whole thing can kind of just become like a arguments.map maybe. And then dot collect. What is this? Checked function argument. So we need a checked function argument. Checked function argument. This guy. A probably has a label. Cool. Oh no. This is the exact same thing that happened last time. So we could clone that guy. Shucks. The value is see, I definitely don't want to. Even if you're generating it yourself, I imagined you would use an IR. It makes it easier, no? How close to assembly would the IR be? Like how? Yeah, what would that look like? Could you maybe give me a little bit of an example of what that would look like? Because I was thinking I'd just try to go straight to assembly, and then if I see like common patterns, I can kind of like abstract them away and stuff like that. But what's the syntax in this language for passing functions as parameters? It's just normal like first class function syntax. You just have like call, and then you could have like a label, and then you just pass the function. You mean for like the type definition? Function type definitions look like this, like type, return, type, like that. We'll just give this a shot. So that's an expression. We need a checked expression. So we need self.check expression. Oh man. Okay, so we can't do this. I imagine it would be pretty close. If you do register based IR, then adding two numbers would be like add R3, R1, R2. If it's so close though, what's like the real benefit of going to that before going to assembly? If you could just go straight there. Alright, so I need to extract this away a little bit. I'm gonna say do this at the end, but first we're gonna gather arguments together. So name stays as name, argument becomes args. Type int gets passed through, I guess. This is the type of the result. All right, so I need to type check these args. So I need to look at the optimizations. Easier to go from IR to assembly and from AST to IR, then from AST directly to assembly. Pretty sure Rust has like 3 IRs from the for the borrow checker. Really? Well, yeah, maybe it'll be worth looking into. But I also feel like it could be the kind of thing we could make as an abstraction later. Check the zip function on iterators. For what? Oh, you mean for zipping together arguments and the parameters. Is that what you're talking about? Is that what you're talking about? Because I kind of want to loop through the parameters and okay, so I'm going to say let type look up for type checking. Yeah, but for type checking specifically arguments against parameter types, right? Look up type. Wait, we don't have a type here. What are we doing here? Function call. How can I get a hold of that type? Oh, here we go. So I can say look up variable and pass it name. Self.cur scope. So I have an option of use size and a use size. What are these again? It's like the variable ID, the var name, and no. Variable ID and the type ID, right? Okay. Var name and the type ID. So var ID and type ID. So now we have a type ID. What in the world are you saying? Oh. Var ID type ID else error variable not found name and now we have the type ID and the variable ID. And now we can go get the type of this thing. Let function type equal self dot types type ID. Ugh. I'm getting this problem all over the place. Wait, if an if block returns an option, then else could be an operator on options. Come again? Wait, an operator on options. That does make sense, actually. Am I doing a JIT? I'm not doing a JIT. No. I'm so excited when you complete Lovely. Yeah, I'll be excited too. And else uses that option. That's not a bad idea, actually. I like that idea. Having else be an operator. We could do something with that. All right, but my current grief is that. Oh, can I borrow that? There we go. That's better. Yeah, on the /syntax level, totally. Designing the syntax of a language is much more fun than actually implementing it. You know, I kind of think it's the opposite, actually. I've enjoyed actually writing code a lot more than all of our long discussions about syntax. This, to me, is what's fun. So we have a function type now. It better be... Okay, so we should say... There we go. I don't really need... Oops. Okay, so then else... So we get the parameters. So else, otherwise, if it's not a function thing, then we're trying to call a variable. Like it's a function. So let me go make another error type, because that'd be a good error type. Variable is not, or attempt to call or I don't know, just variable is not a function. Name string. Down here, we'll just return there. Oops, we need to make like a variable is not a function. All it does is take a name, oh, and a span. Span, variable is not a function. And do that, okay. Variable is not a function. Very nice. So now we have these things. I don't think we're going to need most of them. I know I just need the parameters, right? Or I might do need the return type, actually. Not sure about that. So then... So how does zip work? Parameters.zip. iter.zip. Zip, the other would be like arguments. Oops. That's so good. That's so cool. Okay, the only problem with the zip thing, I'll need to do a little check to make sure that the all right, because doesn't zip, like, if one list is longer than the other list, it just like only does the first ones from the longer one, right? Both of them should have exact size iterator, I think. What does that even mean? Don't I need to check? Shouldn't I check first that they're the same size and then do the zip, because it'll just ignore it, like if there's extras in one of them, right? So you can check the length. Okay, yeah. So I should check the length right here. Check length. Okay. So I'll make a new kind of error as well. Although I'm starting to feel like these little error creators are kind of dumb. Cause yeah. I don't know. Well, maybe they're not. Incorrect number of, or incorrect arg count. Expected usize got usize. Okay. Then why does it feel like there's something crawling on my head? Okay. Incorrect arg count. Expected becomes usize, and got, oh wait, that stays the same. Got becomes a usize. This becomes incorrect arg count. Expected and got. Still feel it. Ugh. The built-in types. Okay, cool. So then, yeah, let's go here. I'm going to say let num params equal parameters.len. Let num args equal arguments.len. If num params isn't equal to num args, then return error. Incorrect arg count. We expected the number of params. We got the number of args. And this becomes expert.span. And I suppose we could just inline these. I kind of like it this way though. Cool, that's nice. So now we can zip them together. So we'll go param arg in parameters.iter.zip with arguments dot, what do we got here? Function argument and a param. Okay. Let's do, so yeah, how do we check this? What's on a param? It's got a type and a kind. And then arg has a value function parameter type. So we need to check somehow that the label's right. But how do we check that the label is right? It almost like needs to go on the type. Arg has a label, but param doesn't. Param is a function parameter type. Alright, I think that needs to live on the type. Function parameter type should have a pub call site label, which is option, right, of string. Check params is a checked function. Checked this guy, right? Oh no, we gotta do another. Yeah, that's kind of what that. Wondering if I should just refactor this now. I think I should, because it's making a lot of ugly things. So, all right, let me do that. So I'm gonna say this just is a struct. It has all this and all this. It doesn't have any of that. All right. It has an it always has an internal name, and then it can be labeled is a boolean at call site. Internal name and external name. Yeah, type ID is a type ID. Cool. So then we get horrible problems. Excuse me. And I really wonder if the AAST should be totally different too. I feel like it should be the same. Internal name, external name. And then what was the other thing? Labeled at call site. All right, and then let's go fix the parser real quick. Function parameter. Where's this name coming from? Oh yeah. Label that call site would be false because this is if you see a tilde. External name would be none. Here would be labeled at call site. internal name becomes that. Label.callSite is true. That was easy. So now back over here, we have some real issues. I don't have the match on this param. Right? I should be able to just like maybe just comment this out for a second. Or keep, okay, so wait. Well, it's basically some, okay, we'll just kind of rewrite it, but get rid of this. Just pass along all those things. Do we need to clone these still? And then that actually made everything easier. I don't even have to clone these anymore. Man, sometimes you just change things and you just know it's meant to be that way from the beginning. Okay, so that should totally work. Okay. What else do we need to fix? So this guy too, maybe it'll fix these issues. Probably not, but it might. All right, so we don't have to match on P anymore. We can pretty much just, yeah, we can just get the modifier. We can literally just go straight to this step. And then here, we can go to here. You don't have to clone that. Probably still have to clone that one. Yeah, we gotta clone that one. All right, we got rid of one clone. All right, the call site label. Wait, what was this? Uh, yeah, okay, it'd be p dot external name, right? Oh, we do have to clone one of these. Or both. So I didn't actually fix the clones, but it did make it look a lot nicer. All right, on the whole, I think that was a win. Shucks. Yeah, that's fine, actually. Because it really is what we're doing. And this is an error. Well, okay, that's tolerable for now. If we have performance issues, we'll deal with them. All right, so okay, so then we're checking these parameters against their args. So basically, what did that do for me? I now have parameter has a call site label. Perfect. And arg also has a label. Okay. So I'll check that first. So I need to check the types. I need to check the wait, arg does arg? Yeah, it has a value. Dot. Oh, it's got a kind. Wait. It's an expression. Oh, I need to check that. Okay. So first I'll check the label. So right. Then we need probably some new kind of error. I feel like this error thing could probably pull that into its own thing at this point. Error.rs, and then pull all this into here. And then import some of these things. Cool. So now it's happy about that. And now mod is not happy. No, not a parser error. Oh, it's not pub. Okay, we're all happy. So there's that. I kind of cleaned this up a little bit, and then so what point are we at here? Oh yeah, here we are. Oh yeah, I was making a new kind of error. So if I have incorrect arg label, expected would be a string, got is also a string. Make a new one of these. Incorrect arg label, expected is a string, and then this becomes label expected and got. Cool. So then here, here. Our label we expected param dot call site label. Oh. Unwrap. We can unwrap that because it's an optional. We got arg dot label dot unwrap, and this would be expr dot span. That's fine because it's an error, so performance doesn't matter when we're erroring because we're not going to finish anyway. Okay, and then we have param and argument. Yeah. So that checks to make sure there's this they're the same, and then we'll say let checked arg expr equal self dot checked expression arg dot value. Where is it borrowed as mutable? I mean as immutable. Which of these? Wait, so where are these parameters coming from? Oh, yes. I mean, what can I do here besides clone it? That's probably the best way, right? Anybody in chat have a better suggestion for what I could do here? Parameters was gotten from... Wait, parameters came from up here, where we index into self types to get it. And so it's an immutable borrow of self. You think it has to be cloned? Okay. All right, we'll clone it. So then we have this as a result, which we should be able to do that on. Now we have a checked expression. The type hint isn't a type hint. It'd be param dot type. Dot scope. No. Doesn't wait, what? Okay, so I need to look up this type. Wait, what? How do I get a type ID from a scoped type? Shouldn't scoped types hold on to a type ID? Yeah, shouldn't they? Or... well, that'd be like holding onto their own index, right? So you could also say, well, that's not a horrible idea. They could just hold onto their own index. That'd make some stuff easier. Let's just do that. Well, then you have to give them an index. No, that's not a good idea. That's not a good idea. I take it back. It was a bad idea. I just need to find it'd be like self.types. There's no like index of. scoped type needs to right, if you can't find that type, then you had issues. Do I have like a I feel like I could almost just unwrap there. That should never happen. But that's not necessarily best practice. I thought this would never happen. This will probably be funny later on. So now we have a type ID, which we use here. So now we have a checked expression. And now what do we do with it? We have args. Checked function argument. Okay. There's that. You can use map instead of a for loop and collect the results. Yes, I could. Except for then I couldn't return out of the function with these errors, right? Yeah, it doesn't change anything. But how would I, if I was inside of like a closure inside of a map, then any return would just return out of the inner closure, right? And it wouldn't return out of the containing function. So wouldn't that complicate this a little bit? So then this, what is that one? The res type should be the return type, right? Which is we have here. Why isn't that handy? Equal self dot types dot position What? This is preposterous. What? Oh dear. Oh my goodness. Ugh. Good griefers, Rust. If a type is copied, it does not need to be cloned, so maybe check your types for that. Yeah, but I don't want to clone scoped types. I mean, to copy scope types. Because they can get kind of big. Oh, and I also can't copy them because they have strings in them. Good griefers. And I could literally clone this entire thing. Or not. Okay, I feel like fundamentally here, it's almost like hinting at the fact that my like data structure for like holding on to scope types is like messed up. Don't you think? Types is a vec of scope types. And then I'm just indexing into that with these indices, which are type IDs. I wonder if Can you not use the index whenever possible? That would be copy and clone. That's not a bad idea. Like on a scope type, the return type should be, oh, instead of another scope type, it should just be an index. Which is a type ID. Is that what you're suggesting? That's not a bad idea at all. And the function, oh, this is way better, guys. You were gonna suggest the same thing. Why didn't you suggest it? Okay, this is gonna save me a lot of grief, I think. So then you can just do this. No? And here we can do this and this. Just joined after a break, needed a moment to catch up. Okay. Well, sweet. This is way better. Fantastic, really. So we don't even need to do this whole dance. Oops. Types, position, type. So we don't even need this. What was it? Param.ty. Voila. I don't even know where I am at this point. Oh, I'm still in function call. Cool. So then, what were we looking for? The return type? We could just use the return type, no? Wow. So we just like, you know, dereference this. That's not how this works. Listen. It's a reference to a box? This is ridiculous. Oh, they don't need to be boxed either. Clever monkey. Clever monkey. There's no reason to box a type ID. Where else am I boxing? Box. Okay. No reason to box that. So now I just do this. Ta-da! Uh-oh. Shoink. We don't box that. There's an error somewhere. Okay, can I borrow? Oh, it's the same thing. It's the same thing. Why aren't you copying? Return type. Isn't there like a copied thing? Param.type. What is going on here? Somehow references inside of indices, but then there's the self-reference lifetime problem. Yeah, I'm not really familiar with that concept. What I don't understand is why this is upset about this when this is copy. It's literally a usize, or a reference to a usize. And even when I clone it, it's sad. If I deref it, wait, I'm borrowing here. And then I'm borrowing here. And this has like nothing to do with it. Oh, so you tell me it's these two. I borrow it here. I'm confused. What should I do? I mean, that fixes it. Maybe that's fine for now. We never used this for our ID, did we? So just clone the scoped type for now. All right, that's fine. It's fine. Let's run some tests, see if this is even working. Wait, we do have, this is our test case, right? Okay. Shoink, so this is to our AST. So yeah, we changed kind of the model. Function parameter name is no, that got removed. Label that the internal name is X, external name is none. It's labeled at call site, it's not. Cool. This one's labeled at call site true, yeah. And we have variable decal, it's X, it's assigned to a function call, yada yada. Yeah, okay. Pretty confident that's good. This is what I'm less confident about. Okay, this is the checked program. So this is the what we had before, right? Label that call. This is the new stuff. Okay, so the X got replaced with internal name is now X. Yep. External name is none. Label call set. Yep. Type is still the same. That all worked. Okay. Here we go. Checked expression. Why does it have a type ID of 2? Oh, because 2 is unit. That's perfect. 2 is unit. That's good. And then it's a variable decal assigning X to a checked expression, which is a function call, which has a type ID of 0, which is for ints. So this whole thing evaluates to an int, which is perfect because it does return an int. Same add, its arguments are label none, value, checked expression, int literal, type 0, type int. Perfect. Another int literal 9, which type 0 is labeled with 2. The variable ID becomes 3, and then it's referenced down to the very bottom. We reference. I take it back. Why does it say variable ID 0? Variable ID is 0. Come again? This is fine. Something's funny, isn't it? I need to see the whole thing. And then over here, I need to see this. Okay. Thing returns unit as a variable declaration. It is binding add to a function, which we already checked and it looks good. The variable ID is 2. Okay, because x got 1, x got 0, y got 1, add got 2. Let me make another one called x that we're binding to a function call. That's getting a variable ID of 3. Oh, I figured it out. This x thinks, because this became 0, this was 1, this was 2, this guy became 3. This didn't know whether to reference 3, which is called x, or this one, which is called x. Oh. Gotcha. So it sounds like we never left the scope you're supposed to. Yeah, that's exactly what I was going to say. You never leave scopes. Yes. Function. Where does this end? Down here, return that. Wait. New scope. Let original scope equal self dot cur scope, and then we're gonna go back to original scope at the very end. Or let's try it again. That worked, didn't it? Yeah, so now the x is of type 0, which means it knows that this is an int, which is kind of nuts. Because yeah, because it's just the result of this, which it knows returns an int. So it's an int, and its variable ID is 3, which is correct, right? Because this was 0, 1, 2, 3. And so x is referring to 3. Except. That is nuts. Wowzers. Type checking function calls. All right, that was a lot of fun. So that was a pretty easy bug to fix too, which is nice. I'll probably stop there. I've been going, 4 hours and 40 minutes. That's kind of a long time. Yeah. Thanks everybody for watching. The small window on the bottom left that shows the keys is an OBS plugin. No, it's this thing down here. It's this thing. It's called Keycaster. It's open source. It's on GitHub. All right, cool. Thanks everybody. I'm gonna cut it there, and we will continue tomorrow probably. I'll send a link and stuff in the Discord. Until then, goodbye.